Hello, ladies and gentlemen. Root Beer here, wishing you well. We're going to continue our look at the 2018 Euclid Math Contest with question number 8. So, if you'd like to, I'd encourage you to pause the video and not proceed without trying the question for yourself. Don't read solutions. Just give yourself some time to play with the question so you can really see where you might struggle, what you would need to sort of work at, and how far you can actually get on your own. Okay, because that's the real judge of how well you'll do in any upcoming Euclid, is not how many of my videos you've watched or how many solutions online you've read. It's how well can you actually do with these questions. How extensive is your knowledge of math. Okay, so question number 8. We're starting to get a little more difficult here. Let's dive in and take a look. It is a complete written solution question. It's our first one of the contest, but the next ones will also just be completely written. Sort of, the last 3 questions are meant to be the tougher questions, the ones that are meant to sort of separate the scholarship seekers from the scholarship getters. Okay, so we've got 8a. Determine all values of x such that log base 2x of 48 cubed root of 3 is equal to log base 3 of x, or 3x, of 162 cube root of 2. Okay, so immediately I'm sort of drawn to these cube roots. I'm a little suspicious. I also note, oh, these are logarithms, and I actually breathe a sigh of relief because I often find, and I've said this in the past, logarithms and sort of function-y based questions are sort of meant to scare people more than they are to be particularly difficult. Logarithms sort of have a reputation of being nasty. I often find that students in my first-year calculus classes, they really, really hate logarithms, when logarithms only boil down to a few basic properties. So as long as you're comfortable with those properties and being able to spot, yes, I should switch it around like this, logarithm questions are actually a bit of a joke. Okay? Now, I say that, I haven't finished the question, and it might be that this is a really hard logarithm question, but I don't think so. Usually it's, rearrange it. If you don't like logarithms, you can often shift it so that it's a question involving exponentials, which somehow people are completely comfortable with, despite the fact that it's just sort of the mirror image of logarithms. Okay, so the first thing I'm going to do is, and this might be important to you if you need a little bit of a refresher on logarithms, log base, let's say, log base p of q is equal to r means exactly the same thing as p to the r is equal to q. Basically, you're asking, what do I have to raise p to in order to get q? That's all it is. So when I see something like, well, we've got to write it up, so let's be a little more precise. Let's say something like, let y equal log base 2x of 48 cube root of 3. Okay? Then, because they're equal, we know that it's also equal to log base 3x of 162 cube root of 2. Okay. So, we might say rearranging 2x to the y is 48 cube root of 3, and 3x to the y is equal to 162 cube root of 2. Okay, so this is 2 to the y, x to the y, and we've got 3 to the y, x to the y here. Now this is 2 equations and 2 unknowns. We want to probably start trying to solve for things, cancel out, get everything all in terms of one variable. And something that catches my eye right away is, oh, I've got an x to the y and an x to the y. I actually saw it up here, and that's why I chose to expand it out for you. So if we were to somehow find a way to cancel out this x to the y by, I don't know, dividing. So we could do something like, we'll put the 3 on top. So 3 to the y, x to the y, over 2 to the y, x to the y, is going to be 162 cube root of 2 over 48 cube root of 3. But of course now these x to the y's cancel out, and I don't need to know what x is. This is 3 halves to the y. And over here, well, 162 is 2 times 81, so that's 2 times 3 to the 4. And then I get a cube root of 2. And this is actually, 48 is 3 times 16, which is 2 to the 4. And so the numbers are really, really working out here. So I get 3 to the 4, 2 to the... cube root is to the 1/3, so I've got 2 to the 1 plus 1/3, so 4/3. All over 2 to the 4, 3 to the 4/3. Okay. So when you've got the same base, and you're doing a division, the exponents subtract. So we get 4 minus 4/3, or 12/3 minus 4/3. That's going to be 8/3. So I get 3 to the 8/3. And the same thing happens in reverse. 4/3 minus 4 is going to be negative 8/3, or just an 8 to the 8/3, but on the bottom. Okay, so this tells me that y is 8/3. Great. I didn't want y. Well, I don't need to know y. I just need to figure out what x is. But this should help us out, because now that I know y, I can just take one of these equations that has x and y, plug in the y, we'll all be set. Okay, so we'll flip the page. So then 2x to the 8/3 is 48 cube root of 3. I'm going to cube both sides, so 2x to the 8 is going to be 3 cubed, and then we're going to have 2 to the 4, so 2 to the 12. And then 3 here, so that's 2 to the 12, 3 to the 4. So this is 2 to the 8, x to the 8 over here. Divide by 2 to the 8 on both sides, so we get x to the 8 is 2 to the 4, 3 to the 4. This is 6 to the power of 4. Let's fourth root both sides. So we'll get x squared is going to be 6. So this to me suggests x is going to be plus or minus the square root of 6. But, and this is something you sort of pick up after years of working with logarithms, you sort of always have to be on the lookout and worried about your base. Okay, not until you take a sort of a complex analysis course very far into your math undergrad will you ever even get the hint that you can get negative bases when it comes to logarithms. So, we have to be careful, because we don't ever want to see something like log base minus 1. That's a no-no. That doesn't happen as far as high school contests are concerned. You can never do something like that. Okay? So we have to be careful, because the x is in the base here. And so if I took the negative square root of 6, I'd be looking at log base negative 2 root 6, and that's not good. So we'll say, but x is the base, so it must be positive. Thus, or therefore, x equals root 6 is the only solution. And you can just see most of that came about just by rearranging my logarithms to an exponential situation. I wrote log once, twice, and that's it. And I just had to be careful at the end and use the fact that we were told a logarithm expression in order to rule out the negative. Okay, but I think you only lost 1 mark for keeping the negative root 6 in there. I don't know. It's been a while since we marked these. Okay, so that's A part. We'll flip the page because we still have B part, which looked like quite the big geometry question. What have we got? In the diagram, PQRS is placed inside a rectangle ABCD. Okay, so it is a rectangle. The pictures do not lie. There are right angles here. Oh, and this one's also a rectangle. And it's placed in 2 different ways. First, sort of flush up against it, and then it's been slanted. It's on its side. Okay. And each of the corners is on a side of the square. Okay, we're told AB is 718. PQ is 250. Determine the length of BC. Okay. So just from knowing those two dimensions and that the one rectangle fits snugly in there, we can get the other dimension of the big rectangle and therefore the other dimension of this smaller rectangle. That's actually an important thing to note, is that QR is the same as BC. So I'm going to draw those two pictures first, and I'm already starting to think in the back of my mind, what can I do? I'm seeing a lot of right angles, so I might think trig, but I haven't been given any specific angles, so might not be actual trig. It looks like it, or I might say, at some point, here's this theta, and we never actually work out what theta is. That's fine. Okay, so we've got our pictures, and the length that we want is, call it x, I guess. Total distance here is x. This is x, this is x, this is also x. And then we've got 250. So there's a 250 there, a 250 there, a 250 there, 250 there. I'm wondering if I might need to overlap these two pictures in some way. That's a thought that's running through my head. And I know total distance here is 718. So 718. And that means that, what have we got left over? 718 minus 250. This is going to end up being 468. Okay. Well, I'm really liking these right angles over here. So, what could we do? Well, let's call this, they've got x, so let's call this y, and then maybe this is z, and then this would be x minus z, and then we'd have 718 minus y over here, and I'm sensing some similar triangles, which is probably a good thing. So, say P, B, it was Q, C, D, R, S, A. I'm pretty sure that's the way it looked. Yep. So you would say, start off by saying something like, let PB equal Y. Oh, I don't need this Z because I guess it's the square root of 250 squared minus y squared, but I'm going to leave it as is and make my equations look a little nicer. But if I need to, I can get this just with one variable. So we'll say BQ equals Z. Then AP is 718 minus Y. QC is X minus Z. Let's also say BC is X. And I sense some similar triangles, so I'm also going to say angle BPQ equals theta. We'll give it a color. Green. Okay. But that's theta, so this is 90 minus theta. And then we've got a 90 here, so that's 180 minus theta, so this will have to be theta, and this will be 90 minus theta. And we will get similar triangles. We just need to briefly write that up. So similar triangles here might help us. So then AP is 718 minus Y. QC is X minus Z. Angle BQP is 90 minus theta. Angle RQC is theta. Angle SRD is equal to theta. Angle QRC is 90 minus theta, etc. So, and you can write etc. as long as it's clear that you're just chasing the one angle around your picture, and you do have a clearly labeled picture. So, triangle APS is similar to triangle... I gotta make sure I get the order right. So, SAP similar to PBQ, similar to QCR, similar to RDS. And since PQ is equal to SR and PS is equal to QR, we get congruency. The two big triangles are congruent, and the two small ones are congruent. So PBQ is congruent to RDS. Okay. So that means that I also get 718 minus y down here, and x minus z here, and a y here, and a z here. Okay. So, can we get... What I want is an equation just in x. I think that might be the best thing for us here. But I'm not entirely sure as to how to get that. Well, we can see, and you could write this up nicer with the Pythagorean theorem, but you can say y squared plus z squared is 250 squared. And this is, I think, the bigger one. X squared is equal to x minus z squared plus 718 minus y squared. So I think if we're careful and expand this out, I don't remember off the top of my head what 718 squared is. I'm just going to leave it as is. Minus, getting out my calculator, 718 times 2 is 1436. So there'll be a y there, plus y squared. So these two here are 250 squared. And these x squareds should cancel. And what do we have? We'll have 0 is equal to minus 2xz plus 250 squared plus 718 squared minus 1436y. Okay. I'm a little upset because we've got two equations here, but three unknowns. I'm trying to think where we might get... I don't think we're going to get any information there. I'm trying to think where we might get our additional piece of information. We need one more piece of information to get the third, to be able to solve for the third unknown. Well, to be able to solve for any one of them, but really. What can we do here? Oh, yeah, similarity. Right, similarity. I just, because we've got similar triangles, so y is to z as x minus z is to 17 minus y. So y over z is the same as x minus z over 718 minus y. Okay, so that's good in some way. Cross multiply. And we'll get 718y minus y squared is equal to xz minus z squared. multiply by 2, because I notice I got minus 2's and minus 2 times 718. So we'll get 1436y minus let's bring the maybe I can't get rid of that. I will say minus y squared is equal to 2xz minus z squared. I think we can turn... Yeah, So let's say... We'll bring the y over to the other side. Do we want to bring the y... Let's say multiply by -2. So those are pluses. So now minus 1436y plus y squared minus z squared is equal to minus 2xz. Add 250 squared, which is x squared plus y squared. Actually, no. Let's say sub it in first. And you might want to be labeling these things as you go. So that's 3, that's 4. Technically, these are 1 and 2. So we'll get 0. So sub into 3. So the minus 2x gets replaced. So minus 1436y plus y squared minus z squared plus 250 squared, which of course could have been written as y squared plus z squared, and this will cancel out the z squares, plus 718 squared minus 1436y. So we'll cancel out the z's. Shouldn't have combined a y and a z in the first place, but I didn't know where this was going. So we'll get 718 squared minus 1436. That's going to be 2872 y plus 2y squared. I can divide by 2 on both sides. And we're going to have just a nice little quadratic. So 718 squared, I don't know what that is. Divided by 2, I'm really not liking this. What are the factors of 718? Maybe that'll be easier to work with. 359, I don't know if that's a prime or not. It's not a multiple of 11. Not a multiple of 13. How about a multiple of 17? Not a multiple of 17. Try a multiple of 19. I don't know. It's 2 times 3, 59. Actually, right now I've stopped caring whether or not it's a prime. So divide that by 2 minus 1436y plus just a single y squared. We copied that right? Yes, we did. So that'll be 2 times 359 squared minus 1436y plus y squared. So do I have to quadratic formula this, or is there a nice factorization? I don't think there is, but let's play around with it for a moment. 1436 minus 359. Divide that by 2. No. I think when in doubt, quadratic formula is the way to go. So by quadratic formula, y is equal to negative b, so that's just regular 1436 plus or minus square root of all over 2. So b squared, so that's 2 times 718, so that's 4 times 359 all squared minus 4ac all over 2. We can start dividing by 2, so we'll get 7/18 here, plus or minus, get rid of this 4 and one of these 4s. And so we'll be left with square root 359 squared. There'll still be 1 4 there, minus that 2 there. And it's not over 2. Okay. Did we do that right? Feel like yes, we did. One of those 4s pops out. One of those. Yeah. Okay. Okay. So that's 7/18 plus or minus 359 square root of 2. All right. So can we do 359 times the square root of 2? It's 507, so yeah, we can subtract that. Shouldn't add it, incidentally, because y is a side length, so y is less than 7/18, so obviously we're going to have y is equal to 7/18 minus 359 root 2, which is actually going to be 359 2 minus root 2. And we just want x, don't we? Right? We just want x, so we just want this length here or this length here, whichever one. And so we've got y. Let's solve for x. Using, actually none of these equations are particularly enticing. Yeah, I don't like any of these equations for trying to solve for x, but I guess we got to do it somehow. So, well, if that's y, what's z? So let's find z. So square root of 250 squared minus y squared. Is y squared even a nice number? I feel like it isn't. It's 210.297 something or other. So that's y, and then if I square it, yeah, just horrible numbers. Definitely not liking this. I feel like the quadratic should have been easier. I feel like it could have been something non-quadratic formula-able. So I just want to double check. Have I screwed something up? And yes, actually, I think I just found something. I multiplied by -2 here, got the -2 there, but did not get the -2 there. I'm really sort of disturbed by the numbers we were using, but we've got some fixing we got to do. So it made it. So I did successfully make them positive, but I never multiplied by 2. Or else gonna have to clear this page, and we'll just skip over them in a moment. Okay, so this makes me feel a little bit better. So now we can say. Although this might leave an extra z squared lying around. I don't know. 2y squared minus 2z squared is equal to minus 2xz. Fine. Sub into 3. And we'll get 0 is minus 1436y plus 2y squared minus 2z squared plus a y squared plus a z squared plus a 7/18 squared minus a 1436y. I'm going to add 250 squared, because that's y squared plus z squared to both sides. And we'll get a 250 squared is minus 2872y plus a 2y squared plus a y plus a minus a 2z squared. So minus 2z squared, there we go. Plus the y squared plus the z squared plus another y squared plus another z squared plus 718 squared. I think we've got everything. Yes, although if the numbers get weird and I'm starting to feel uncomfortable, we'll go back and double check and we'll find that I've made some other mistake. There go the z's. We'll get 4y squareds. 718 squared minus 250 squared minus 2872y plus 4y squared. I can divide by 4 everywhere, so that makes me happy. Dividing by 4, we'll get 718y here, plus a y squared here. We'll get 359 squared here. And then minus 125 squared here. And that's a difference of squares. Just on a hunch, I'm going to figure out 359 minus 125 is 234. And then 359 plus 125 is 484. And if I add those up, I get 718. Yeah, this is what it's like. They don't make the numbers super awkward on purpose. So that's how I was sort of able to feel that, these numbers are weird. Maybe I've done something wrong, because 2 minus root 2, while not bad, I feel like the answer is going to have to be an integer just because they gave us integers and not a lot of other weird stuff. And I'm much happier to see this. 234 and 484, these are going to be possible values for y, so let's go back in and finish it off. But just wanted to explain that, you do enough of these contests, you can sort of feel out when things are going wrong. And you come to expect this sort of thing. Like if I wrote a Polish contest, I haven't written many Polish math contests, so I don't know if they are sort of trying to keep things all integery. And I wouldn't be able to feel out a Polish math contest, but I've done a lot of Euclid, so. Y could be either 1, except y is less than 250. 250 is the hypotenuse of, what was it, PBQ. Just a little explanation there. So that means y is 234. Now, I still have to figure out x, and we're still going to have to find z first. But that's the square root of 250 squared minus 234 squared, and this I also expect might be quite nice. Just going to grab my calculator. 250 squared minus 234 squared is 7744, and I feel like that's a square of something like 48 or something like that. Square root of 7744 is 88. Okay. So z is 88, much better. And now we can use those ratios we had. Y over z is equal to x minus z over 718 minus y. So that's 234 over 88 is x minus 88 over 718 minus 234. Let's clean some of this up. So 718 minus 234, it was 484, I think. We just had it on the other page, didn't we? So 484. Multiply on both sides. Well, I think we could divide 234 by 8, maybe? No, not by 8, but by 2 at least. So 117 over 44 is at least a little cleaner. But yeah, I'm still going to have to multiply that by 484. So 56,628 is equal to 44x minus 44 times 88. Can I divide both sides by 44? I can indeed. Oh yeah, because this is 44 times 11. Doy. Okay. So I get 1287 is x minus 88. So I add 88. And x is equal to 1375. And that's my final answer. So other than this middle part where I sort of was led astray, well, not led astray, but I made a silly mistake and it almost cost me a lot of time. So always be careful even when you're multiplying. I was so focused on making the 718 into the minus 1436 that I forgot to do the same thing to both of these. I was just focused on this part, and that's a big problem that I had there. But other than that, it went smoothly. Everything did turn out to be integers, so that's good and comforting. That's, of course, assuming I haven't made another mistake somewhere, but I don't think so. Usually integers is something that, if you see it, it's probably a good thing. If all your calculations came through as integers, you might be on the right track. Anyway, that was question number 8. Up next, of course, question number 9. I will see you for that in the next video. Until then, take care and have a wonderful day.